picture. What do you want? Find the force on the 5 microcoulomb one. I'm going to relabel this. This is 5 microcoulomb. We want the total force on this one. Okay, tell me. What's the force from this charge on this one? What's the direction? They are all positive, right? Therefore, they will repel each other. Therefore, the force will be this direction, right? And how about the other charge here? It's the same repel, right? Suppose this is F1, this is F2. What you want is F1 plus F2, right? So the total force is somewhere over here, right?
Right.
Okay. So basically speaking, you want a force as a vector. It equals F1 plus F2, right?
Mm-hmm.
And if you try to play the game in components, you need something here, which is coordinate system, right? Otherwise, you can't. So therefore, if I were you, I will say this is X direction, this is Y direction. Okay? All right. If I make this line longer, what's the angle here? 30. What's the angle here? 60. Okay? This is 60. And what's this angle? 60. Okay. If you set up a coordinate system like this, you need to find the component of F1, right? How? You just do parallelogram, right? Therefore, one Y component is here, X component is here, right? This is F1. You know this angle. Can you find the X component? Oh yes. Can you find the Y component?
Yeah.
Oh yes. You do the same thing on F2, right?
Right.
Exactly the same, you see? You have one here, and basically you have two Y component. Y from F1, Y from F2, right? Okay, therefore you keep going here. It will equal to F1 is something times I plus something times J, right? This is F1. Then plus for F2, right? Okay, therefore you just fill in something here. What's the X component of F1? It's this segment. X component of F1. It equals hypotenuse times cosine 60, right? Therefore, here is F1 cosine 60. And for the Y component, which is this part, it's the opposite side. Therefore, it's F1 times sine 60 degree. And similarly, you will figure out the two components of F2. Therefore, do some simple calculation. Then you will get a solution. Okay? This one is not that hard because all the angles are figured out. And what's the side of this equilateral triangle?
Each side, 0.5
Yeah, the
meters.
side. 0.5, right?
Yes.
Yeah, 0.5, 0.5. When you apply Coulomb's law, the distance is a constant 0.5, which is R in the formula. Okay. Again, I have to remind you that when you go home, try to do your homework. Don't touch them. Open your notes. Study those examples I give to you. For example, after you reviewed the first example, then cover it. Use a blank paper, try to reproduce it. Okay, if you can do that, okay, move on to the next one, do the same thing. The next one is going to be harder, therefore, you just try your best to reproduce it. If you have problems, you can open your notes to look at the notes and then continue. Then you did it. But this time you needed some help, right? It doesn't count. You cover your notes, do it again. Okay, if you still have a problem, you can look at your notes, no problem, but you finish it. Then third time, until the try that you can completely do it yourself without any help. Then stop, move on to next example. You need a lot of scratch paper with you, okay? I don't like your notebook because it's very hard to tear it off. Just some separate papers. And when you finish your homework, you should use a lot of scratch papers on the table. That way, you just change my thing to yours. It no longer belongs to me, it belongs to you. Therefore, in the exam, you will feel it so easy. Nothing hard. Okay, simulation of the examples first. Then move on to the homework problems. And I hope next time, before the lab, when you come here into the lab, you turn in your homework. It takes 15%, right? Okay. Be sure to practice physics, not practice your mathematics. Okay? Show me your physics, not mathematics. If you use some strange symbol stand for your numerical solution, you're welcome to do that. Okay? Don't click on your calculator, do those complicated calculations. It's a waste of your time. Got it? Okay. Well, that's all. And plus another thing. Next week we have Monday off, holiday, right? Usually we will cancel all the lab classes. Do you want me to do this? Next week on Friday we only do lecture, no lab?
Sounds like a good idea.
Okay. If you support this idea, okay, we can do it. But only next week. The other week we have to do experiments here. Okay? Alright, that's it for today.